Once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And we are going to talk of example 15 on page 137 of Pure Mathematics 3. We have been explaining this book, Pure Mathematics 1 to 4, Statistics and Mechanics, in this channel, just to help students who are following the international Pearson specification wherever you are. And in the previous video, we have understood that if y is equals to tan x, then dy dx is sec squared x. We have outlined how we landed into this. So search my video, Differentiating Trigonometric Functions, example 14, and you will see that. We are also told that if y is equals to tan of kx, then dy dx is k sec squared kx, just following the general differential rules. And in example 15, part A, y is equals to x tan 2x, and you can already see that this one is in two parts. It's a product. There is a u and there is a v, where u is x. So this one is already a product, so we must apply the product rule. So if we make x to be u, then du dx is definitely 1. If you make v to be tan 2x, then dv dx is 2, just in this format, sec squared 2x. So if you wish to apply now the dy dx, which should be u, according to the product rule, dy dx is equals to u dv dx plus v du dx. Then we can capture that and bring it over here and talk about u, which is x, dv dx, x multiplied by 2 sec squared 2x, plus now the v, which is tan 2x, the v multiplied by the du dx, which is just 1. And at that point, you can already see that our dy dx becomes something else, 2x, because of, you open this bracket, 2x sec squared 2x plus the tangent of 2x, and that is just like it. If you look at part B, we are told that y is equals to the tangent to power 4 of x. Now, this one is in different setup. It is already in it's going to require what we may call the chain rule, because we can write y to be equals to the tangent of x raised to power 4, whereby we must differentiate what is outer. We must differentiate what is actually outer and then differentiate what is inner. And in this particular setup, we are going to have dy dx. Here we're going to use chain rule. We are going to use chain rule. In the first one, we used the product rule and we explained that. Here we are going to use chain rule. The dy dx is 4, differentiate the whole term, 4 tangent of x raised to power 3, of course, plus the differential of the inner part, the function of x itself, which is obviously the sec squared of x, because here we are having tan x. So at the end of the day, we are going to say that dy dx is 4 tan cube of x plus sec squared of x. And that is the final submission as far as that one is now concerned. So here we are, we have differentiated two trigonometric functions using the forementioned or foreland uh, um, rules, basically the chain rule, the product rule, and even the quotient rule. So again, follow my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and of course, share widely, subscribe, and like the channel. All right.